Hi guys, welcome to my channel. In this video we are going to solve questions about engineering hydrology, and the question will be about the evaporation from the lake and from the basin. So let's solve the question. First I'm going to start with this question. The following data were observed at the Demirköprü Dam site on the Gediz River in June 1971. Find the monthly evaporation in millimeter from the reservoir surface of this dam. If there were a Class A pan installed nearby the reservoir, what will be the monthly evaporation observed from this pan? And now we can see all the data are given. Storage at the beginning of the month is this, and storage at the end of this month is also that. Average of the average surface of the reservoir in month is this. This is the area of our uh, lake. So mean inflow. This is the water comes to the reservoir, okay, meter cubic per second as a in term. So we're going to make some conversion here to determine the evaporation. Amount of water used for the power generation. This is going to be loss, but we can add as a minus. And average seepage rate in month also will be negative. So now we have this all data. So let's write the equation and determine the evaporation. So the mean inflow, we are going to make a conversion for mean inflow to meter cubic. Now we can see it's meter cubic per second. We are just going to add the meter cubic to month. Okay, so this is going to be something like that. For this one, 15.8 multiplied 86,400. This is the second in one day, okay? Second in a day. And multiply 30, this is the number of day for month. And we are going to obtain 40,953,600 meter cubic as the water it comes to that dam in 1 month. Okay, now this is the mean flow. So let's calculate also the seepage, because seepage is liter per second. We have to convert it to the meter cubic to month to get this all in terms of just one unit to solve the question. So for seepage, it's also will be equal to 424.38. This is the liter per second. Now we can see this is liter per second. So we are going to multiply it. Look at here. This is 1,000 liter. Okay, 1 meter cubic, because 1 meter cubic is equal to 1,000 liter. Sorry, and multiplied 86,400 multiplied 30, because I told you this it's previous, and what is that? So this will be equal to 1099992. I guess, sorry, I'm gonna check. Yes, 96. This is also meter cubic. Okay, so now let's write it. I have this all, so I can calculate it. This is going to be the storage at the beginning of the month. Beginning, okay, 495.5 multiplied 10 power 6 meter cubic, and I have also plus this one inflow. What is inflow? It is inflow 40,953,600 meter cubic, and these are the positive. Okay, and let's write also negative, the amount of water used for the power generation. Okay, this is loss because it used to generate the energy. So this is going to be for power. I'm going to write it like this, and 50.5 multiplied 10 power 6 meter cubic. And also I have a seepage here. This is also loss because we lost this water from the dam lake, minus what was that? It was here actually as I calculated, sorry, seepage 109992.96 meter cubic. And also we have an evaporation is also negative because we lost the water from the surface of lake. Okay, so when we take the summation of these all, we are going to obtain at the end of the month. Look at here, it's given at the end of the month, the water in the reservoir, it is this 476.4 multiplied 10 power 6 meter cubic. When we take the summation of all this, okay, and the evaporation will be equal to 8,453,607.04. This is as the meter cubic. Okay, this is evaporation. Now we obtain as evaporation in the meter cubic. So let's calculate it. It is in millimeter. Okay, then we also calculate for the pan. So how we are going to calculate for millimeter? If you have an evaporation in meter cubic, if you divide it to the area of this reservoir, you are going to obtain it in meter, and we'll convert it to the millimeter. So we are going to obtain the actual evaporation. Okay, so this is going to be something like this. Let's divide it to 42.5 multiplied 10 power 6 as meter square. Okay, from here it's going to be 0.198 as meter, but when you convert it to millimeter, multiply with 1000, you are going to obtain it as, sorry, not 0, it's going to be 198 millimeter as the actual evaporation. So what is the formula of actual evaporation to calculate from the pan? The evaporation of pan multiply a K coefficient. What is K? K is equal to 0.7 because it's class A. Okay. So when we write here 198 equal to evaporation pan multiplied 0.7, so we are going to obtain evaporation pan as equal to 284 millimeter as for pan. Now you can see we solved the first question. We obtained the evaporation actually and for the pan, because in the question it asks like that, what will be the monthly evaporation observed from this pan. So now it's okay, it's solved. So let's solve the second question. It is 1.5, problem 1.5. And it says that a certain basin is expected to receive 120 millimeter of rainfall in June, where the evaporation from the soil surface and transpiration are estimated together as 40 millimeter. Total infiltrated water depth in the month is assumed to be 12 millimeter if the area of the basin is 73 kilometers square, and there are no other losses. Determine the surface runoff from the basin in millimeter depth, meter cubic volume, and liter per second average rate. So let's obtain what is the losses and what is the water we gain. Okay, so the first one is going to be, look at here, this is the rainfall. Okay, this is the rainfall, so this is positive 120 millimeter, but we are going to divide it 1000. This is a positive, I'm going to write like that, and when I multiply with 73, multiply 10 power 6, because I'm going to multiply with area, and I'm going to obtain the total water as comes, sorry, the total water comes as a rainfall. Okay, when I multiply the area. So, and this one will be equal to 8,076,000 meter cubic. Now this is comes to the ground as a rainfall. So, and we have also as soil surface runoff, okay, and the transpiration. Sorry, evaporation from the soil. Sorry, this one evaporation from the soil, and plus transpiration also 40 millimeter. So this is negative, right? Because it is evaporation, it goes, we lost the water. So 40 millimeter to over 1000. to convert it to meter, okay? And sorry, now are you confused? Multiplied 73 multiplied 10 power 6 equal to 2,920,000 meter cubic as the loss. And also we have the total infiltrated water depth in the month is assumed to be 12 meters. So the water goes to down. So what is that water? Is 12 millimeter, okay? What I'm over 1000 millimeter, and this is going to be also a meter, and multiplied 73 multiplied 10 power 6 is equal to 876,000 meter cubic. So now we multiply it with the area to obtain the total infiltrated water in this, and we multiply the area to obtain the total evaporation and transpiration. And also this one, when we multiply the area, you are going to obtain the total water comes as rain, okay? So, and now it is okay, we obtain the amount of that we need, that what is the loss and what is we gain. So take the summation of them, because this is negative, and this is positive, and you are going to obtain from the summation of them, let's write them here, 876 minus and also minus the infiltrated water. So this will be equal to 4,964,000. Yeah. And this one is in the as a meter cubic, okay? Now we obtain as a meter cubic. What it says in the question, determine the surface runoff. Okay, this is the surface runoff we obtain. This is the surface runoff from the basin in depth and in meter cubic. So now we obtain in meter cubic. It's okay. So let's calculate in the millimeter. For this one, how we are going to calculate the in millimeter, okay? The depth in millimeter, it's going to be calculated like this. Now we have at the meter cubic, if we divide it with the area of this basin or this lake, okay, we will obtain in depth in meter. When we convert it to the millimeter, so you are going to obtain the depth. So it's going to be like that. And this is going to be meter cubic. Obtain the area. What is the area? Let's check the area. Yes, 73 multiplied 10 power 6 as meter square, okay? 73 multiplied 10 power 6 as meter square, and this will be equal to 0.068, and this is meter. So let's convert it to the millimeter and multiply with 1000, and we are going to obtain 68 millimeter. This is the depth of water in millimeter as for runoff. So let's calculate liter per second average rate. So liter per second is going to be, now this is this one is the meter cubic month actually, okay? Because look at here, this is for the month, yeah, for June. Let's write an equation here. This will be equal to 4,964,000. This is meter cubic month, okay? Meter cubic month. When we multiplied, this is 1000 liter, and this is 1 meter cubic, because you know 1 meter cubic is equal to 1000 liter, and we are going to multiply it 1 month over 86,400 multiplied 30, because 1 month is this amount of second, okay? In 1 month, this amount of second. So this will be equal to 1 915 liter per second. I showed you this conversion because sometimes some students they confuse how they are going to convert from the meter cubic month to, of course, liter per second. So this was for them. Now the both questions are solved. Thank you for watching. If you like these videos, if you want to see more of the videos, please subscribe and share with your friends. If I did something wrong, please warn me. I'm gonna fix it. See you for the next question. Take care of yourself.